Okay, so in this lecture, we're going to go over basically how to do this worksheet. And I just want to make sure that you all thoroughly understand the intricacies of how to calculate a standard deviation, variance, and sum of squares by hand. And also the importance of calculating all of this to ensure that you thoroughly understand what each of these are. So first of all, I told you all in class, whenever I give you whenever I give you something in class, whenever I give you a question on the exam, I'm always going to make sure that you know whether or not it is a sample or a population. And once again, a sample is going to give you statistics. Population is going to give you parameter. And once again, the reason why we're doing all of this, because that's the big question, right? Why are we doing all of this work? Why are we calculating all of this information? Right now, all that we're doing is describing the data. We're in the unit 1, so descriptive statistics literally means we are describing the data. We are describing the data. So right here, like I said, I'm going to give you information to let you know whether or not we're dealing with a sample or a population. So you'll see Mr. Kent opened up a comic book store called Clark's Comics and Collectibles. He hired 15 employees and recorded pertinent information about them. Below is the information on some of his employees. So right away we know that this is, what is this? Is this a sample or a population? Okay, this is going to be a sample because there's 15 employees, but there's only six employees here. There's only 6 employees here. Okay. So, so we've got your 6 employees. Okay, you've got their ages, their birthdays, their badge color, their position, years working, and their pay rate. Okay, so those are your variables. And looking right up here, the name of the employees, that's going to be nominal data because you can't put those in order. Age, that's going to be ratio. Birthday is going to be interval because 0 doesn't really mean 0. In this case, 0 actually means time from 1900 AD. A lot of times, most times it's time after 0 AD. Badge color is nominal because it just happens to be the color of a badge. Now, if I were to say that the badge colors signified a rank, that could, like belt colors, that could be ordinal, but badge colors don't signify a rank here. They're just different colors. Position, cashier, assistant, cashier, those are different positions, and they are, this actually is, so those are ranked in order. This should say store manager, there we go. And then that's supposed to say assistant manager. So those are ranked, cashier being the lowest, assistant store manager being next, and then store manager being the top. And then years is ratio, how many years they worked, and then finally pay rate is also ratio because these both have meaningful zeros, as well as this. So now the question is what can you calculate for a standard deviation and a variance and range, actually? So in order to calculate the standard deviation and the range, you're going to, and the variance, you're going to follow a very specific set of practices. So next thing that you're going to do is, or the very first thing that you're going to do, which if you look on your sheet, I'm going to pull the sheet up right here. To calculate the mean, do this. To calculate the variance, do this. To calculate the standard deviation, do this. That's what we're going to do right now. Okay. So make sure that you've got your sheet out and you're following along with that. So we're going to do the pay rate. So pay rate is 9, 15, 10, 11, 18, and 15. So the first thing that we're going to do is do average. And you just highlight what you want for your average. Okay, so the average is 13. The other way to do this is equals sum, and you highlight everything that you want to take the sum of, and then you divide that sum by the number of observations, and that will give you the average pay rate. So it's the same exact thing, so 13. So right here, minus x bar. So x bar is the mean. So you're doing the pay rate minus x bar, and then equals this minus this. So -4, and you can just drag it down. -4, 2, -3, -2, 5, 2. So I put in here the formula first, and then I just dragged it down. And then what happens if you add all of these up to 0? So equals sum. I'm going to show you what happens when you add all these up to 0. Or sorry, when you add all these up together. When you add all these up together, it should always equal 0. And the reason why is the sum of the deviations from the mean is always going to equal 0. So remember that. The sum of the deviations from the mean is always going to equal 0. If it doesn't equal 0, then you did something wrong. So you notice you've got -4, 2, -3, -2, 5, and 2. The problem with this now is that you've got negative numbers. So what do you do in order to take away the negative numbers? In order to take away the negative numbers, we need to actually square them. Okay, so equals -4 squared. Okay, and once again, I can just drag this down. I'm going to show that to you one more time. Equals this. Okay, so I clicked on the cell that contains the deviation from 0, and then I made the symbol to raise it to a certain power. So I raised it to the second power. Okay, and then I just dragged it down to fill these formulas. So these formulas are all raising the cell to the left to the second power. So these are all the squared. This is also otherwise referred to as the squared deviations from the mean. Okay. Okay, data. Let's see here. Wrap text. Squared deviations from. That's better. Okay, squared deviations from x bar. Whatever. Then from there, we're going to do equals sum, and we are going to add all of these up. Okay, so that's the next step. You add all of these up together, and so this is also otherwise referred to as the sum of squares, because it's the sum of the squared deviations from the mean. The sum of the squared deviations from the mean equals the sum of squares. Now the question is, should we divide this by n, just n, or should we divide this by n minus 1? And if you look at your formula, let's look at the formula. Okay. Okay. We know that you divide by n minus 1 if you're dealing with a sample, but you divide by n if you're dealing with a population. And we know that we are dealing with a sample, so we're going to deal with n, divide by n minus 1. So what is n minus 1? N is the number of observations that you have. So we've got 6 observations, and we are going to divide it by, so we've got 6 observations, so n minus 1 is 5. So we do equals 62 divided by 5, which this right here gives you, the variance. Okay, and this variance, is this variance a statistic, or is this variance a parameter? Okay, it would be a parameter if we were dealing with population data, but because we are dealing with sample data, this right here is a statistic. So the variance, this is the statistic for the variance, which is 12.4. So what is the standard deviation? All that you got to do is equals SQRT, then put in parentheses, and take the square root of it. So 12.4, take the square root of 12.4, so it's going to be 3.52. And in this class, I only want you to round to 2 decimal places. So 3.52. Okay. Next, let's come down here, and we're going to do the same exact thing. Okay. We already did this in class, so I'm just going to do it super quick. Equals average I'm going to show you how quick you can do this. So equals, or just 21, 21, 21. Just keep doing that. Equals this minus this. We're going to bring this down. Okay. Then we're going to do equals this raised to the second. We're going to bring this down. And then we're going to equals sum. And so the definition of what we're calculating right now is the sum of squares, which is 64 of squares. Okay, sum of squares. Okay. And then are we going to divide it by n, or are we going to divide it by n minus 1 for the variance? And once again, because this is a sample, we're going to divide by n minus 1. So how many observations are there? There's 6 observations, so we're going to do 6 minus 1 is 5. So equals 64 divided by 5, and then equals square root of that, which is 3.5777, which we're going to round, to 2 decimal places to 3.58. So years worked. Okay, so we already did pay rate, which I'm just literally going to Control C for this and do pay rate, because we already did that, and then Control C. Okay, so we've got pay rate done. So we're going to do years worked. So equals sum, and we're going to do all of these, sum, so we're going to add up all of these together, and we're going to divide it by the total number of observations. The total number of observations is 6. So the average is 4, or the mean. So 4, 4, 4, 4, 4, 4. Whoops, went a little too far. So we've got minus x, so 1 minus 4, so equals 1 minus 4, which gives us negative 3. 4 minus 4 gives us 0. 2 minus 4 is negative 2. 4 minus 4 is 0. 7 minus 4 is 3. 6 minus 4 is 2. So equals sum this, because I want to check, does this equal 0? It does equal 0. And if the deviations from x equals 0, then you know it's right. Okay? So it's always good to check. So always add those up, and they should always add up to 0. And so the next thing that we're going to do is we're going to square it. And the reason why we're squaring it is to take away those negatives. Okay, so we're going to square it. We're just going to bring it all the way down. So squared, 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 squared. So we've got all these squared. Then we do equals sum of this. And you notice this is a pretty small number. So the sum of squares here is 26, which is really small. But sometimes it is. The sum of squares is really small. So we're going to take the sum of squares, and are we going to divide it by n, or are we going to divide it by n minus 1? Same thing as before. N minus 1. So equals 26 divided by n minus 1, which is 5. And why are we doing n minus 1? Because we're dealing with a sample. And so this sample, doing this divided by n minus 1 gives us the sample statistic of the variance. So now we have the variance, and in order to get the standard deviation, we've got to take the variance equals square root, SQRT, of the variance. Or sorry, yeah, of the variance. So let's round it to 2 decimal places. 2.28 is the standard deviation, or 2.28 is the average number of years. Okay, so of the employees that work there, the average amount of years that employees' employment years deviates from the average number of years is 2.28 years, which I know that's a lot to say. In other words, the average number of years that everyone worked there is 4 years. But on average, people deviate from that by 2.28 years. Next, we've got birthdays. Now, what's really cool uh, about Excel is birthday or day of the year is actually stored in a form that is the number of days since 1900. So these are the number of days since 1900. So it's going to be a little bit different. So we're going to do equals sum, and we're going to add this, and it's going to be the number of days since 1900. But we need to do sum divided by 6. Okay, so this right here is the average birthday. Let's see what day that is. All that you've got to do in order to change it back, go day, or type, and come in here and do short date. So the average birthday is the 3rd of March, 1997, technically. Okay, so 35,492.2. So equals this minus, and I don't want to type, or no, that's not what I want to do. Okay, so I'm just going to copy and paste, Control C, and I'm going to do Control V. Let's try this again. Control C, Control V, and I'm going to paste just the value. So now there's no formula in there, it's just the value, and I'm going to put this in there a bunch of times, and now we're going to do equals this minus this, which gives you the deviation from x. So this is the number of days that each deviates from x. So this looks pretty crazy. Should these still add up to 0? Because it doesn't look like these are going to add up to 0. Well, let's see. Equals sum. Okay, now I'm going to tell you what this is. Okay, this is otherwise known as rounding error. This is 0.0 with 11 more zeros, or really 10 more zeros, but 145, so it's essentially 0. When you get something like this, it's basically saying 0. Okay, and if I would not have rounded this to just one decimal point, if I would have let it go on forever, then it would have kept on. Then it would have been completely 0. So over here, we're going to do equals this raised to the second. Okay, and we're going to scroll. We're going to drag it all the way down, and we're going to do equals sum. And there we go. That sum of squares is huge. Okay, that's huge. 9 million. That's the sum of squares. So if it's so large, it must represent a population. Nope. Still a sample. So equals this divided by 5. Okay, so divided by 5. So this gives us the variance. This is the sum of squares. And now we're going to do equals square root of this. And now this is a really good question. What does this mean? 1,345.65. What does that mean? That's the number of days. So if you want to know how to say this, okay, the average birthday of the individuals, we're going to change this to date, that work there is March 3rd, 1997, but the average, the employees deviate on average by 1,345 days from that date, or 1,345.65 days from that date. Okay, so the average birthday is March 3rd, 1997, but on average, employees deviate from that date, or employees' birthdays deviate from that date by 1,345.65 days. Or if you wanted to, you could put it in years, equals this divided by 365. So on average, individuals deviate by 3.669 years. Individuals deviate by 3.69 years from that date. And I'm going to, go like this, 3.69 years. So that's how you do this. These are all the correct answers. Divided by 5, divided by 5. That's also divided by 5. This is divided by 5. If we were to have divided by 6, then it would be a sample, or it would be a population. And once again, the long form right over here, this is the long form of how to do it for pay rate. So right here, if you actually want to work out the formula by hand all the way, because I know some people like to do that. I'm not knocking that at all. You would do it by this formula right here. So you take the exact same data and you just plug it in with the real formula. This is the variance, and then in order to do the square root, you just put square root in there. So that is the end of this, and I hope that this was beneficial for you. Feel free to let me know if you have any questions. Once again, you can't do variance and standard deviation for the qualitative, but you can do it for the quantitative. I'm trying to think if there's anything else. I don't think that there's anything else that I need to say about this. Hope you guys all do really well on your quizzes, and have a great weekend. Thanks.